right, so we have made it to the level 4. There's 2 videos for the level 4. We're going to do more composite transformations. So for number 1, we are doing a reflection over the line x is equal to -3. So that's this line right here. And then we are doing a reflection over the y-axis. That's this line here. So first we're doing the reflection over the line x is equal to -3. So since A and B are on that line, they're going to stay. And C is 1, 2, 3, 4, 5 units away. So C prime is 5 units away on the other side. So this is my new triangle after the reflection over that yellow line. Now I'm going to do my reflection over the red line. So A is 3 units away from that red line. So A prime is going to be 3 units away on the other side. Sorry, A double prime. Same with B double prime. And C prime is 1, 2, 3, 4, 5, 6, 7, 8 units away. So C double prime will be 8 units away on the other side. Okay, so this is what your new triangle looks like. And now for number 2, I'm doing it backwards. I'm first going to reflect over the y-axis, and I'm going to reflect over x is equal to -3. So first reflecting over the y-axis, A is 3 units away. So A prime will be 3 units away on the other side. Same with B prime. And C is 2 units away, so C prime is 2 units away on the other side. So this is what your triangle looks like. So then, now reflecting it over the line, x is equal to -3. A is 6 units away. A prime is. So A double prime will be 6 units away on the other side, and same with B double prime. And C is just 1 unit away. So C double prime would be 1 unit away on the other side. So this just confirms that composite transformations, it does depend what order you do it in. Now, if we look at numbers 1 and 2, what do we notice about the lines of reflections? You should notice that your line of reflections for both of these are parallel lines. Whoops, I spelled parallel wrong. And then, how could we write number 1 and number 2 just using one transformation? So if I look at my original triangle for number 1, to get to my pink triangle on number 1, I just essentially slid this black triangle over 1, 2, 3, 4, 5, 6 units to the right. So I could write it as a translation 6 units to the right of triangle ABC. Whoops. To get triangle A double prime, B double prime, and C double prime. For number 2, to get from the black triangle to the pink triangle, same thing, but I'm going to be going backwards, so to the left, 1, 2, 3, 4, 5, 6 units. So that would be -6, 0. So both of these were the same exact distance, only one I translated to the left and one I translated to the right. So both of them were 6 units. So what do we notice about the distance between A and A double prime in both number 1 and 2 in relation to the distance between the lines of reflection? So the distance between the lines of reflection are 3 units. And from A to A double prime, it ended up being 6 units of a distance between those 2 points. So actually, the distance between the parallel lines was doubled to get my translation. All right. So when we do a double reflection over two parallel lines, that always will result in a translation. And the translation is going to be doubled the distance of your parallel lines. All right, number 6 and 7. Now we're doing a double reflection again, but this time I'm not doing my double reflection over parallel lines. Instead, for the first one, I'm going to reflect over the x-axis and then over the y-axis. So I'm doing a reflection, a double reflection over, I actually don't want to answer number 8 yet because number 7 is going to be a little bit different. So these are just intersecting lines. You may say, oh, they're perpendicular, but that's not what I'm actually asking for in 6 and 7. So let's first do our translation, or sorry, a reflection over the x-axis. A stays. B is 3 units away. So B prime is 3 units away on the other side, and same with C. Now doing my reflection over the red line, the y-axis, B prime is 3 units away. A prime is 3 units away. And C prime is 8 units away. So this is my resulting figure after that double reflection. Now in number 7, we are doing first a reflection over the y-axis, and then a reflection over the line y is equal to x. So I'm not focusing just on the lines of reflections being perpendicular. I'm focusing, I'm focusing on the lines of reflection being just intersecting. Okay, so for number 7, my first triangle would look like this. After I reflect over the y-axis. And then I'm going to reflect over the line y is equal to x. So B prime will stay. C is 1, 2.5 diagonals away, so C double prime will be 1, 2.5 diagonals away. A is 1.5 diagonals away, so A prime will be 1.5 diagonals away. This is what your triangle looks like. Okay, so how could we write number 6 using just one transformation? Now, to get from my black triangle to my pink triangle, this would not be a translation. Instead, what happened is I rotated this triangle 180 degrees about the origin. And for the next one, this would be to get from the black triangle to the pink triangle. This would be a 270-degree rotation, which I'm actually going to write as a negative 90-degree rotation, and I'll explain why in a moment. Actually, I am going to make it 270 degrees instead. Okay. So it says, what do you notice about the measure of angle A? O stands for the origin, and A prime. In relation, sorry, this should say A double prime. In relation to the angle developed by the two lines. So my two lines of reflection actually create a 90-degree angle for number 6, and my angle of rotation was 180 degrees. So in this situation, the angle between, let me be more specific. Whoops. The angle between the two lines of reflection was doubled. And it's the same case for number 7. Number 7 is a little bit more difficult to see. However, with number 7, the two lines of reflection actually create a 45-degree angle here, which means that if I do 180 minus 45 degrees, that leaves me with this angle being 135 degrees. And if I do 135 degrees times 2, I do get my 270-degree rotation. If I did a negative 90-degree counterclockwise, if I do 45 times 2, that also gives me a 90-degree clockwise rotation. So the angle between the two lines of reflection was doubled. So to recap, if you are doing a double reflection over parallel lines, it results in a translation, and your translation is double the amount that the distance between the parallel lines were. If you are doing a double reflection over two intersecting lines, then your resulting transformation would just be a single rotation, and the angle of rotation is double the angle that is produced by the two intersecting lines of reflection. So that is what you can take away from this lesson. We are going to do one more lesson in this unit, and then we're done.